Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the 10th video in my series on threads. Now, way back in the first video of the series, I showed some slides like this, where I introduced the concept of the thread pool. And what I said was that when a main process needs to create a worker thread, it gets it from the thread pool. And then as these worker threads complete and their work is done, then they are returned back to the pool where they can be efficiently reused. So it turns out this is not true all of the time. It really depends on how the main process creates the worker process. So this video is a little bit of a correction and clarification from that first video where I talk about really the two different ways that threads are provided to your process. So the distinction is between thread pool threads and what are called dedicated threads. And it's pretty much like it sounds. When you have a dedicated thread, it's been created for your process and just given to your process, and you kind of own it from start to finish. And most of the examples that I've shown you so far actually were creating dedicated threads. If you write your code slightly differently, as I'll show you in a minute, rather than getting a dedicated thread created from scratch, you get one assigned from the thread pool, which is a little more efficient because you're not incurring the overhead of creating and tearing down the thread. You're simply pulling it out of the pool. So let's look at the code. It won't take too long, and we'll look at a few different ways you can start up these workers and either get a dedicated thread or a thread pool thread. For this demo, I wanted us to have a way to keep track of and log activity in the thread pool. So I created this little class called the thread pool monitor. And it's based on the exact same pattern we used for our folder monitor back in video 8. So if you're interested in these start and stop mechanics, go ahead and watch that video. The main thing for today is right here in the main function, the monitor thread pool function. And we are taking a look at our threads in a couple ways. The first thing is we are looking at our current process, so process.getCurrentProcess, and we're looking at the threads collection. That's actually a process threads collection. So this will give us the count of dedicated threads that are assigned to our process. Then we have a couple of functions in the thread pool class here, one called getMaxThreads and one called getAvailableThreads. So by doing a little subtraction where we take the max number of thread pool threads, that's how many are in the pool, minus the available threads, that gives us how many thread pool threads we're actually using at the moment. So on our polling interval, this just writes out the number of dedicated threads and the number of thread pool threads. So I modified our main function here to actually start the thread pool monitor on a 1-second interval. Let's just run this and take a quick look at that. So if we enter, it'll start our thread pool monitor. And you can see we've got 18 threads dedicated to the process, and none of our thread pool threads are currently in use. The next thing I did was I set up a little thread pool test class, which is basically a scaled down version of our threads versus tasks class from the last video. And you can see it just goes for I equals 1 to some count, and it starts some kind of test job using this job function, which logs the beginning, does something CPU intensive, and logs that it's finished. So I think a duration of 3 is just fine, and a count of 5 is just fine. So what we need to do now is fill in our test. So why don't we start by just making a dedicated thread, the same as we've done in almost all of the videos in this series. So we can say new thread, giving it some job in the constructor, and then we can go ahead and start it, giving it the number I. This should start 5 threads. So let's run this and watch what happens with our thread counts. Enter to start the monitor and enter to start the test. And what you can see is the number of dedicated threads jumped from 18 to 23 because we started 5. And then as they finished, it dropped back down to 18. And we are not using any thread pool threads. So when you create a thread explicitly using the thread constructor, you are creating a dedicated thread. So how do we create a thread pool thread, or how do we allocate a thread pool thread? So we're going to change this here, and we're going to use the thread pool class, and we're going to call queueUserWorkItem. And it expects a callback, i.e. a delegate. That's the function that we're going to run, and it can also take some state. So we'll pass in our number I as the data for the thread. So this is how you explicitly start work on a thread pool thread. Let's go ahead and run it. We'll start the monitor and start the test. And now you can see our thread pool usage has jumped up to 5. It looks like we got a couple of dedicated threads allocated. I'm guessing that has something to do with the plumbing for managing the thread pool. Maybe the first time you dip into the thread pool, it spins up some sort of thread that helps manage the thread pool. I'm not really sure. But what's clear is that we went from 0 thread pool threads in use to 5, and then back to 0. Now, there's one other way we can do this, which is really interesting. What about using a task, just like we did in the last tasks versus threads video? So to do that, the first thing we want to do is we're going to make a copy of I, just like we did before, because we're going to be calling a lambda function and passing data in, and we want to make sure we're passing the right value in. And I'm just going to copy and paste it to save a little typing, because it's got a lot of punctuation, but we're calling task.run, and then we're calling a lambda function which takes no parameters, and here it is, and the body of the lambda is calling some job passing in copy. So this is launching 5 tasks. So do you think these are going to be dedicated threads or thread pool threads? Let's find out. We're going to start our monitor and then start our tasks. So there's your answer. When you run work on a task, it runs on a thread pool thread automatically for you. So this is another advantage of using tasks, that you automatically take advantage of the thread pool. And the thread pool is going to be more efficient because you're not incurring all the overhead of creating and tearing down the threads. So I still would maintain that for a long-running sort of durable thread like our folder monitor, it makes sense to create an explicit dedicated thread. But for shorter running or frequently created and stopped little jobs, tasks are the way to go because they will give you automatic access to the thread pool. All right, there you go. Now you understand what the thread pool is. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.